In the last video, we got the Lewis structure for carbon dioxide, CO2. But when we got to the point where we were forming multiple bonds to satisfy the central atom in the end, we found that we could share in multiple different ways. If you took a lone pair from each of the oxygens and made a double bond on each side, that would give you one structure. If you took both of the lone pairs to share from that oxygen, it'd give you this structure. And if you took two lone pairs from this oxygen and shared them, that would give you this structure. Which one of these structures is the best? We're often going to see this situation when we're forming multiple bonds in the end, and we have to actually add another rule onto our recipe in order to handle that. Now, that has to do with assigning formal charges to the atoms in the structure. The one with the structure with the lowest formal charges is the best. It'll have lower energy than the other structures. And we can cross out the structures with the higher formal charges. Now, what is a formal charge? It's not too different from oxidation numbers, but we don't use the rules for oxidation numbers for assigning formal charges. The rule is a lot simpler. The formal charge on an atom is equal to the number of valence electrons on that atom minus the number of sticks and dots around the atom in the structure. Now you're going to be able to assign a formal charge to every atom in the structure. Let's use this rule to assign formal charges to the atoms that we have in this structure. Okay, now look at this oxygen. Let's assign a formal charge to it. Now, oxygen has got, if we look on the periodic table, 6 valence electrons. So this number of valence electrons on the atom would be 6. Minus how many sticks and dots are around that oxygen. 1, 2, 3, 4, 5 sticks and dots. Now notice this is a little confusing. We're not counting electrons this time. We're counting sticks and dots. And there's 5 sticks and dots around that. And what's 6 minus 5? That's 1, or we can say plus 1. That's the formal charge on that oxygen. Now let's do the formal charge on the carbon. If we look at carbon on the periodic table over here, it's in the column that has got 4 electrons. So we have 4 valence electrons minus how many sticks and dots? Well, there are 1, 2, 3, 4 sticks. So it's 4 minus 4 equals a formal charge of 0 on that carbon. Now let's do this oxygen. Let's see, oxygen has got 6 valence electrons, so we say 6 minus how many sticks and dots? 1, 2, 3, 4, 5, 6, 7 equals minus 1. Now, I've assigned all the formal charges there. Now, what do they mean? When you have a negative formal charge, it means that the electrons are piling up on that part of the structure. When you have a positive formal charge, it means that you're electron deficient. You don't have enough electrons over there on that oxygen. And if you had all the formal charges be 0, that would be ideal here. There's a way to check and see whether you did this correctly. All the formal charges add up to the net charge on your molecule, just like oxidation numbers did. Remember, all the oxidation numbers had to add up for all the atoms in a compound, had to add up to the overall charge. And it's the same thing with formal charges. So here we have a plus 1 plus a 0 minus a 1 adds up to 0, which is the overall charge on CO2. So that's a nice way to check and see whether or not we've assigned them correctly. Now, if I look at this one, doesn't it just look like this one flipped over? I mean, I could go and I could assign all the formal charges to these, but I will notice by symmetry that this one and this one are pretty much the same. So I really have a plus 1 charge on that one, formal charge. I really have a 0 formal charge on that carbon, and I have a minus 1 formal charge on that oxygen. Now let's do this structure on the top. What do I have on this oxygen? Okay, oxygen has 6 valence electrons minus the number of sticks and dots. 1, 2, 3, 4, 5, 6. 6 minus 6 equals 0. All right, this carbon has got 4 valence electrons minus 4 sticks around it, which is a formal charge of 0. This oxygen is pretty much the same as this oxygen over here, but oxygen has 6 valence electrons minus 1, 2, 3, 4, 5, 6. And I'm counting sticks and dots, not electrons, when I do formal charges. Now look at those 3 structures. Which one has the lowest overall formal charge? Well, in this structure, all the formal charges are 0. In these 2 structures, there are non-zero formal charges. So they're not as good as this. They're not going to be as stable as this. These might be what excited states for this molecule would look like. Molecules can have excited states, just like atoms can. But I'm looking for the most stable structure, and that's going to be the one with the lowest formal charge overall. So this one and this one aren't as good as that one, and that's the only one that I would have to write down. Now what happens if I get multiple structures that have pretty much the same formal charges? That's a situation called resonance, and we'll do an example like that in the next video.